We're going to talk about the propel system that drives this machine. This is a closed loop hydrostat. It's a 5,000 PSI continuous duty system. But again, it's a closed loop hydrostat. But there are 3 drive motors that are all in parallel. So this is the closed loop hydrostat pump that drives it. Again, I said it's a 5,000 PSI continuous duty. This machine operates most of the time at 2,500 PSI or less. What that means is every level of pressure and every degree of temperature you pull out of a hydraulic system, you extend its life. This is designed for long life and durability. The motors that drive this, there are the 3 motors. The 2 motors on the back of the machine are fixed displacement motors. This motor on the front is a variable displacement motor. It allows us to get what we call our 2-speed. So we can shift it, and we'll talk about the controls in a little bit, but when we shift it into 2-speed, we now can go up to 9 miles an hour. And why would we want to do that? When we're empty, we want to get back across the parking lot to our tanker and refill and come back and get started working. So we've given the ability to have good control and low speed control for application, but then we can transport and get around pretty quickly. On the propel system, when this machine was designed, the machines in the industry struggled with power. At the time, there were fail-safe brakes were non-existent, and there were the front wheel on the propel were held on by bearing blocks. We've come a long ways in the process within the industry for safety and for durability. We use these Auburn gear hubs, so each wheel is attached to an Auburn gear hub, which is designed to take the abuse as we're driving over curbs, potholes, rough surfaces. It's going to take that abuse. The hydraulics are propelling it, but what's carrying the machine and handling the abuse is the torque hubs. So that's one of the other things that make this such a durable machine. The 2 motors on the back have fail-safe brakes built into them. If there ever is an issue, engine dies on a hill, a hydraulic line breaks, some issue happens in that regards, it's going to stop the machine. We're not going to have a runaway issue that causes someone to get hurt. So safety is the #1 priority when this machine was designed, and it continues to be our focus today. So on the propel, these are the 3 wheels in parallel. On smooth, flat land, that is perfect. There's no issue. It's balanced. The center of gravity of the machine is such that we keep great balance of the machine. The wheels that we have, this front wheel is a foam-filled wheel. The 2 rear wheels are pneumatic. We foam fill the front wheel to add additional weight to this front end for that balancing of the machine. We don't foam fill the rear wheels because it would be a pretty rough ride if that were the case. So we have that pneumatic actuation in the tire to soften the operation or the ride of the machine. The other part of the propel system with this machine and the balance, we're talking about the foam-filled front tire for weight balance and those things. So if we get into loading this thing on a trailer, and we're going up a tilt trailer versus a 3-degree load angle or something like that. If we're going up a tilt trailer, we take the weight off the front wheel, because they're in parallel, that front wheel may want to spin away. And that was a problem on the earlier design machines. The newer machines have a trailer mode, and we have a traction valve. The traction valve restricts flow to the front wheel. So it limits when we put it in trailer mode, and we'll show that in the computer operation. But when we go into trailer mode, it's going to restrict the speed. It's going to lower it down to about 3 miles an hour max. And then it also proportionately adjusts this. So it's looking at joystick position, it's looking at the speed sensor in the front wheel, and it's looking at the relationship of those. And if that front wheel starts to spin away beyond what the joystick position is, it's going to actually proportionally restrict the flow to the front so that it balances the flow and gives us the power to go up steep grades. And we'll actually do a live demonstration and show you how that works later. All right, underneath the machine, there's several things we want to look at. On the far side, we've got a torque hub, there's a fail-safe brake, and then there's a drive motor. There's one on either side. So those are where our rear brakes are. Those are the safeties, right? Spring applied, hydraulic released. These motors are fixed displacement piston motors, and they're all in parallel. Very robust system.